pointers covered today are broadly into the following segments, which are management, planning and efficiency, sourcing, material and finishing, and detailing, which is, I think we are all lagging in that. So Vivekda and Utpalda, over to you on how we can effectively from day one operate everything in our design so that our costs are kept down and our planning is efficient. I think cost overruns are also a big problem because we haven't planned properly. So how do we cover all that? So can you take us
Okay.
through your presentation?
Thank you, Rohit, and thank you, Rajat. Thank you all the viewers right now, the panelists, Utpalda. Uh, on behalf of both of us and the teams, we really welcome you this afternoon session of cost efficacy in real estate. I'll just share my screen so that we can actually go through the presentation. Basically, what we try to do is out of our own works and the research that we did over the years, both the teams in terms of MNC and us, we try to collate and kind of objectivate the entire content to give you a pointer presentation in the following manner. So I think I'll switch over for the screen share. Is this, that's okay, viewers?
Yeah, it's okay, sir.
Yeah, we can see it.
Thank you. So it's very important, we are going through very competitive times. Challenging is a word which is relative, but definitely we have to increase our sensitivity in terms of cost efficacy. We often come down to everything to cost, but there's a process of understanding cost, quality, and time. So the following pointers, not everything can be actually absorbed in this time span, but importantly, whatever we thought that we will be likely to come here. Often we have taken the efficiencies or the parameters of Eastern India, though we have taken a lot of research and data from CREDAI and other good practices, inputs from our clients, engineers around and working in this entire consortium of construction world. Important to start with is when we are talking about the cost, essentially we straight away jump into a system that, that's the way to cut the cost and this is the way to actually cut the cost. And it seems everybody seems to be giving input. While that is a great participation, but we actually need to sectorize our inputs for efficacy. So when we started working on and what are the points, we actually came out, if total cost saving is, let's say 100%, let us see what are the parameters in which windows can cost reduction. So planning and design leads it. Planning and design actually, if we really give our input and thrash it out, our working of your cost can be saved in the stage of planning and design. Detailing is very important, which comes often, and we often, ride over an important factor of detailing and miss a value of 10% in cost efficacy. Material finishing and technology both contribute to almost 50%. Sometimes we have an apprehension, everything will saving upon material. No, that's not all. Even selecting the right technology, building up the way you build up the right project, how this project works in the technology, sourcing technology, sealing technology, vital and very important for 15% of this tax cost saving. Sourcing and management, individually, 10% of the contribution. While we think that everything is project management, no. A good project management, yes, can. And today, every small bit of the cost percentage matter of very vital importance. But sourcing, not only from which place, what material, but there are various parameters of sourcing and resourcing. And that's very important for us to understand. But whatever we do, we have to start with a project initiation document. You see, it's often said, a good start is half won. So if we know how to start our project, we often get an architect and say, let's get design, I need this much, not part of it. That's not all. You need to properly document and start with the PID. a project initiation document, which can be actually gathered from your team, technical team, existing marketing team, your own research, research report, other viability and feasibility reports. But what is important is it should have goals set. This is what your goals are. Your criteria for evaluation, which is often missing. If you do not set the criteria, we think we can actually intervene at every place. Set your criteria. If you want, these are the parameters I want to restrict. For example, a simple thing, you want to restrict your ratios in terms of efficiency. These are the parameters. And I thought that if this presentation can help us actually understand the ratios and the parameters, possibly you will be able to articulate your PID. And very important at this very PID is set up a base budget. Often we start with a great esoteric idea and land up in negotiating that idea. If you set a base budget, it is a fantastic parameter for a designer or an architect or a structural designer or an urban planner to get started on. Base budget at your PID is very important. And then comes the design basis report. Friends, in this basis, 18 to 20% of production can actually work out in these methods. And design of basis DBR, whether it's engineering, whether it's structural, whether it's architectural. Architectural DBR is also of PID. And this is often done in two-tier methods. It's not once. Once the person should come and take inputs, and then the person should actually refine them. So there's a way to take questions and then refine the DBR and do the design, so that your basis is in confirmation with the objectives and the goals, and the design is in confirmation with your DBR. You save a lot of time and energy and actually negotiation of. We don't need to negotiate good designs. Now, often we have seen out of our homework that when we design presentation is done, because we are biting in many ideas, it is often not a continuation of an idea. But at this presentation, I just want to cover the heads essentially. A minimum of 3 options should be worked out with budget evaluation. Now, that does not mean that I'm going to do the detailed design of 3 options. It means that you can do a pre-concept of 3 designs and evaluate them in the budget. Usually much more, and we've seen 1, 2, and 3, almost 33 to 60% of the efficiency in terms of design efficiency from 1 to 3 we can achieve. And this is a normal process of laydown in human psychology or design evolution. And in that process, we should not miss that the estimates are always made, whether it's from the concept, pre-concept, concept, schematics, statutory drawings, and workshops, and then come the CD stages. Estimates are always made and should not be bunked. Every stage estimate can be made, whether it's block estimate or a detail estimate. Of course, when the construction drawing CD, which is a CD state, final estimate can always be made at a CD closure state. And from there, all the attempts should be done to converge to that estimate. So that estimate then should not budge or should not negotiate. But what is important is, how do we come to that efficacy in terms of schematics? 80% of your value engineering is in schematics. Often think that the schematics can be bunked, and the schematics are only a process to out there. Do not take a sanction till you finish the schematics. If you take a schematics, 80%, do your value engineering. Ask your engineer, ask people to participate. Your vendors can participate in the construction drawing workshops. So 80% of your value engineering actually should happen in schematic and not in the stage of construction. At the stage of construction, when you do value engineering, it is always from this factor to that factor. You can never integrate it. That does not bring us cost efficacy. It always brings us a pressing point. You press here, something is coming out there, which you may be not realizing right now, whether it's just time. So do your value engineering in the stage of schematics. 20% in the stage of workshop drawings. And in the workshop drawings, you should participate with the commercial head, the purchase person, or the project people, and get the vendors on board to participate with them in the construction stage. And that is a CD stage workshop. 20% of your efficiency shall come there. Well, to understand, I'll go a little more faster to able to make you understand. Some few heads, though the first stage an architect starts with in terms of planning and design, the 6 overheads that will come. Planning and design, we often look forward to, there is always a ratio that this is the floor pit area and that's the core and that. There are fantastic other points. Whenever we do a design, just do not evaluate in terms of your super built common area percentage. And what we did is just took some case studies and tried to analyze our own drawings. I'm not naming the case studies right now. But what we have seen is designs which have a ratio in residential designs. We're covering two broad aspects, the residential and commercial. We're not spreading much more thinner in terms of our knowledge share. But in commercial, in residential design, just don't look at the super built ratio. Look at the floor plate to the wall surface area ratio. Evaluate your design in terms of wall surface area ratio. So if the peripheral wall surface area ratio to the building is less than 1, over 1, automatically get your budget efficiency pretty well. Sometimes too much of shapes and notches and things like this, you get a very high ratios. So an example, the first case study is 1.12, while the second one is 0.95. That is another perimeter to analyze, and not just super built area ratio. So even the super built area ratio is high than case 1, then you'll see that the case 2 has a perimeter ratio as more efficient. The other ratio, of course, all this is very add to a lot of cost saving. And overall, when I'm writing 11 to 13%, we have analyzed all this cost and parameters and trying to give you a figure so that you can register minimum important data. Important part is, how do you see a floor plate? A floor plate with punches, and how much percentage of puncher can be done. We often see, an example is given out here, that punchers can be ventilation shafts. But if we can reduce a puncher's percentage within 4%, in this case, I was just showing in this place, even for ventilation, we have two shafts, for example, a 3 by 3 meter, a 3 by 3 meter, and in that case, we plan in such a manner that we have a 3 by 6 meter. Don't just see in terms of cost. Of course, a 3 by 6 meter will give you a better in terms of civil costing, but even operating performance will be better. And efficiency, because the smaller that shaft is, even if area is same, you'll have a performance. There will be a drag, a fluid drag will be there because of surface friction, and your performance of your ventilation factor will decrease. So even these punchers, in this case, we are having 7.2% of the puncher on the floor plate. These punchers have to be made lesser, and we should try to keep a punchers within 4% in terms of plans. We also analyzed a very simple way. After the configuration, when you have a planning, you have clustering. 2 blocks, whether come together, separate 2, 3 blocks, how much? And we often come here, again the same thing. We often see a super built ratio, and we conclude. If it's higher super built ratio, we reject the plan. But friends, try to understand. You see case 1, it may be 24% super built ratio, but it has got more components. It has got cores more, and it also got staircases more. A simple corridor, and between a staircase and a corridor, we know that the corridor is going to be less costly than a staircase. So here the staircase component keeps on increasing. So we also need to analyze that. How in the super built area, what are the components, even if you are lesser in super built area ratio in case 1 by clustering. But you'll see that because there are more number of staircases there, of course, the elevators are more, we know that part of it, but staircases are more, it's expensive construction. And that will also consume time. So in these cases, 1 or 2% of super built area ratio should not narrow down for you to not to understand that staircases, even the areas matching a staircase is difficult to make and more expensive to make. And we have seen just a simple, in between the two case studies, one can save 40 rupees per square feet. That's a great amount of cost when it comes down to. So these are the kind of parameters which are important. When you come to a grid formulation, in a system, when you come to a grid formulation, that how you planning, we often used to understand there's a grid of a residential is a residential grid, and we have to follow a residential grid and boil down to a parking. Today, parking is a very expensive proposal. When people come to us and say we don't want to make a basement, it's very important for us to understand that how can a basement be cost effective. It's an ongoing project in Calcutta and fairly known maybe. So here we try to make the full design of residential. We're trying to make sure that the parking grid is actually conforming to the room grid. It starts from a parking grid and then goes up to the room grid. And fairly well in terms of its plan and orientation, we could achieve it. And one can achieve almost 60 to 280 square feet in basement in ECS. the entire thinking that, okay, start with the room, boil down to parking, adjust the parking. No, no. Rather, efficate the parking and create an efficiency of parking and then boil down to the room grid. This is today going to help us because parking is an expensive addition to your planning grid. So while we're planning and design, it's very important that you actually formulate the parking, which we were doing in commercial. Now we often need to do it and also understand that the parking is, if it is mechanical, the grid is no more 2.5, it is 5.5 by 2.6 maybe. So this is the way we need to actually understand, and there's a driveway which is going to be 6 meters parking, or at least 5.65 meters. So that's the way you should look at a grid and then obfuscate and or room grid. Well, while I missed a important point also, just coming my thing. In perimeter design, for commercial, the residential ratio from the floor plate to the perimeter wall, while it is less than 1 or 1, for commercial, try to keep it less than half. So if it's 1,000 square feet of commercial, 1,000 square meter of commercial, keep this one close to 500 square meter perimeter area. And that is the way you get commercial efficiencies in commercial design. That was a point I missed, so I just recollected here. That's about the grid formulation. Often the facades, and this is the office that we're sitting here in right now, that's one of the facades of EcoStation. Often people ask me, this is a fine, why do you do it? And EcoStation is a green building, and it's also it's a simple SGU. I don't need to do DGU because we studied that if we can keep a facade area to 30% of the total area, this is another way to understand commercial. Keep 30% of the facade area as the complete areas of the facades. You will not need and necessitate the need of. Actually, you can go with SGU. There's some inputs of the pointers which are given here. So we also see that the taller glazing in an office works good because it helps travel daylight and view much deeper into the offices. While the residential can be a lot smaller one, the more horizontal stuff, for offices it's better to have taller glazing. And that was the module that we tried to do it, and then we try to distribute here. So that idea is that keep the 30% of the facade, don't go beyond it. Keep it within 30% for the offices. It'll help you to obtain a good efficiency in terms of your glazing. Well, that's about it. Apartment glazing. It just talks about an interesting recent conclusion that the apartment glazing, we can keep it within 12% of the super built up area of the apartment. Suppose the apartment is about, let's say, 2,000. So if you can keep it within 240, super built at 2,000, 240 square meter square feet of your glass surface. That is generally it works good in terms of your ventilation, it works good in terms of your views, and all the deliberations which fenestrations can do in terms of aesthetics also. You do not need to go beyond it. Of course, there's no way to go beyond. You can always go there. There's no limit to go beyond, but it becomes a very expensive proposal. It does not optimize the requirement of view and ventilation in residential sectors in hot and humid climate. Of course, when this can be reduced in terms of your very hot climate, which is north climate and things like this, where ventilation demands are here, this proportion works good enough. And if we can then distribute our glazing in two sectors, we can keep 50 to 60% as full length, full height, and 40% as half. So 60, 40. If you have a full glazing, 100 square meter, make 60 square meter, consider maximum as the tall ones, and you keep others as 40%. You work good in terms of your design, in terms of cost efficacy. One important factor I've always seen, sometimes people do very big kind of a parapet wall, and then they put a tall glazing. It does not work nice. If you put a tall glazing and then you have a parapet which is almost opaque, then you waste the glazing percentage. You are wasting. So try to not to create those kind of designs in terms of planning. One important point before I switch to Utpal for his points on planning and design. All these are very collated research that done by both the teams. So here we understood also the facades costs unnecessarily also increase when we do not plan the service areas properly. So we often give the service areas in front, the utility balconies in front, and we kind of then we do a cape of facade treatment in terms of louvers and a lot of other like design or facade treatment just to take care of our aesthetics or privacy where if we can keep that all open and create all the pipes within an open containment area and keep the utility spaces within it, then we save all that facade costs, which unnecessarily increase the cost. And in this case, 25 to 30% of the facade actually cost can be saved if you can just do in planning and design. So in the next slide, from here, I would request Utpal to carry his inputs on planning and design. Utpal, all to you.
Yeah, thank you, Vivek. Good afternoon, everybody. Welcome to this wonderful presentation, whatever Vivek has taken us right up to this point. Well, we are all passing through one of our difficult period in life, and hope everybody is keeping well. But in spite of that, let's think positive, stay positive, and be in a positive frame of mind. Whatever Vivek said and whatever I am going to tell you today, present to you today, it doesn't have a direct relation to the recent adversaries that we have faced, but it is in general, we must follow all these things to get a real cost. We should not waste our money, as you all understand. So there is no margin of error, there is no margin of wastage. So we have to be apt to our technology, we have apt to our management systems, and we have apt to our design principles. Now, while doing all these years design, I very often come across one topic in discussion while doing some designs with my friends. Is that what is the kg per square feet? Being a structural engineer, I have always been asked one question: what will be the kg per square feet of your steel in our consumption in our project? Well, I smile to them. See, today also, what I'm trying to say that steel is not the only material which you should look at. See, from till now, whatever Vivek said till this time, you could understand that there are so many of points which we should look into to get to a most cost-effective thing. It's not only the steel. I understand that steel is most expensive material, but still we should look into, there are 100, 200 items of work in our project. And if we can look each one of them categorically and critically, you will find that they're at the end of the day when we do a project, yes, we have done our money has not gone down the drain. We have used our money, utilized our money to the right way. Now, I just give you a small example that a price of 1 meter cube of concrete is equivalent to 140 kg of steel, right? Now, suppose as a designer, I use 200 kg of the same element, 200 kg of reinforcement, but I save 2 cubic meter of concrete, then there's a saving to you. See, so there is a balance in design. What we structural designer always try to do is to balance the design and do the, as Vivek said in earlier, that we should do always iterations and options, that if this concrete thickness is 200 millimeter, if I can make it 250 millimeter, is my steel reducing? Is the depth, if I increase by 25 to 30 mm, you remember, let me tell you one thing, that in a concrete, the depth of a member is square proportional to the square of the reinforcement requirement. So a little increase in depth minimizes the steel to a large extent. Now, another topic also which I also come across, which I thought that this is a platform which I should highlight, that I come across and I hear that some of the developers in some other city has come up with a wonderful design and their cost is so less and the steel consumption is so less. Why can't we have the same thing? Now, unfortunately, the structural design is dependent upon geographic locations. It's unfortunate, but it's true. See, for example, Kolkata lies in zone 3 as per the earthquake zone, which is a moderate zone. And wind, my goodness, you have all experienced what it can do. We design our Calcutta buildings with 57 meters per second. which is a little more than 200 kilometers per hour wind. And for example, and comparing this with a city like Bangalore, say, where the earthquake is zone 2, which is mild, and the wind is 30 meters per second, which is half of ours. Now, there also one thing which is, as per the codal provision, it is also provided that you don't need the ductility detailing requirement in a Bangalore building, which means that you directly save 0.3 to 0.4 kg per square feet steel. So, and at the same time, Delhi is in zone 4, which is a severe earthquake zone, and the wind speed is to the tune of 170 kilometers, which is less than ours. So you can understand that how the geographic locations can change the design parameters. Now, adding to our Kolkata's misery, we have a soil condition which is not very encouraging. It's a little poor. Leaving apart some of the pockets in Calcutta like Alipur, Taliganj, some parts of Newtown, we have generally a poor soil, and this adds to our misery and to the cost. So, and at the same time, this in Calcutta, the soil profile varies from place to place. For example, in North Calcutta, the soil is something which is in South Calcutta, it can be different. In East, it can be different. So there is an intra-city variance also. So at the end of the day, what I really want to tell you that each project is unique, and we have to design each project uniquely. There is no similarity as such in this way. We can get a guidance of cost from other projects, but generally it can vary while designing, and the parameters can change. Not drastically, but there can be changes. And at the end of the day, as Vivek said, that the iterations, the options, R&Ds are required, which I tell you one thing, that many of we at our office, we always try to do these R&Ds and improvisation in the structural systems, in the foundation systems, and many of my friends have implemented those R&Ds and improvisations, and the result of these from the continuous R&Ds, you can I'll show you some of the case studies, and they have got the benefit of it, and thanks to them. Now, coming to this slide, this building shape, a shape of a building, it is directly proportional to the cost of the structure. Now, I used to hear from my predecessor in the earlier days that a perfect frame building and with a regular shape and efficient structural system will automatically give you an economic structure. So you should understand the importance of these formations and the structural efficiency. The first point that I could tell you is the symmetry. Symmetry in the structure. Both axis symmetry is a structural dream, but of course at times it gets lost. We design with unsymmetrical buildings, but the pain that we have to take and to meet the kg per square feet, that gets into a nightmare. There is an aspect ratio also, which these are all have come from our case studies, from our relentless case studies that my people are doing with Vivek's help. We have got into a good informations regarding this. The aspect ratio is the length by breadth ratio. Now, ideally, I would say that if there's 2, then it's the perfect. Within 2, it's perfect. But as such, we had designed in the past aspect ratios more than 2. Even we have designed it 3, 4, even probably more than that. But what happens? The more you elongate the building, in earthquake conditions, these behave in a different way, which of course increases the cost parameters. The earthquake forces and wind forces. Everything goes for a toss. Now, the second one, that the height by breadth ratio. Now, this is a directly indication of the slenderness of the building. The more this H by B ratio, the building becomes more slender. And ideally, we would say that restrict it to 5. But I understand in a city like Calcutta, it's difficult. We have designed building beyond 5, 8, even 10. But for that, we need to do some rearguard actions, some dampings are required at the top, because the wind that we have experienced in the recently, it can create uncomfortability to the people living in the top floors. So we have to be very careful while determining the height as well as the breadth. So better if we can keep it within 5. Now, the deep offsets, I understand that it creates a good ventilation into the flats. Now, you can well understand that the deep offsets, the more you put offsets into the buildings, the number of column increases, so the structural cost also increases, and the perimeter, as Vivek said earlier, the perimeter of the building also increases. So thereby, there is an increase in the cost. So if we can do all these things in a collective way, so we can save to the tune of 5%. And one little advice to my friends also,